In this video, I'll be going over problem number 17, which is a nice example of nested conditional proofs. So problem 17 will be the last video for this section. This is the last real key concept, the last twist to get down with respect to conditional proof. Then we'll be ready to move on to our last section, last section in chapter number 7, where we'll go over indirect proof. An indirect proof in many respects works in a similar fashion as compared to conditional proof. So almost through, last problem that I'll go over here in 7.5, conditional proof. So we're given two premises to work with, and the conclusion here is a complex conclusion. We're asked to derive P horseshoe Q horseshoe in horseshoe S. So this might look intimidating, going after that conclusion here. How the heck are we going to pull that off using conditional proof? Well, anytime, and this is the twist here, anytime the conclusion that you're asked to derive has multiple horseshoes in it, this is kind of a dead giveaway, a clear indication that you need to do multiple conditional proofs. You need to take on multiple assumptions, and in fact, nested conditional proofs. So here's how it works. We're going to start by abiding by our basic rule. So don't let this confuse you, don't let this throw you. Again, our general rule is to assume the antecedent of the conclusion we're asked to derive, and there's no reason whatsoever to deviate from that plan. So in this case, the antecedent to the conclusion we're asked to derive is in fact complex, but again, don't let that throw you here. The antecedent, obviously, is everything to the left of the main operator. It's P horseshoe Q. So we'll assume, again, the antecedent. And it's really just as simple as that. P horseshoe Q ACP. But again, as discussed earlier, anytime there are multiple horseshoes in the conclusion you're asked to derive, that's an indication that you need to take on multiple assumptions. So I'm just going to do all my assuming here right at the beginning of the problem, get it over with. Further, by taking on these assumptions right off the bat, I'll have a little bit more ammo to work with. So I've already assumed the P horseshoe Q. I've already assumed that, so we're no longer, at least for now, concerned with it. I've assumed the P horseshoe Q, and I'm now after in horseshoe S. But you'll notice here that the consequent that I now want also itself contains a horseshoe statement. It is in horseshoe S. I've assumed the P horseshoe Q, I'm after in horseshoe S. Again, I'll abide by my general rule, assume the antecedent of what I want. I want in horseshoe S, so I'll just take on another assumption, assuming again the antecedent of what I'm now after. So indent again, take on that assumption, this time I'm assuming in ACP. And now I've got two additional lines here to work with. I've got Q horseshoe Q, and now I've got in. So with those two additional lines at my disposal, let's just follow through with our basic 18 rules. What else can I do? And it opens up a rather obvious move. I can immediately do 1 and 4 mode opponents. Real simple from here. 1 and 4 MP, and I get the consequent O and P. What can I do with O and P? Well, the main operator is a dot, so I can simp, I can common simp. It doesn't seem to be the case that I can do anything with the O, so I'm not going to bother with it. What I could do something with is the P. So again, I'll combine two steps. 5, first of all, switching the order of the conjuncts, and then simplifying ought to be routine. And we get the P by itself. What can I do with that P? Why did I want it? Well, 3 and 6 obviously in mode opponents, and that'll get me the Q. What good did the Q do me? Well, another obvious move, another door has been opened. 2 and 7, this time MP, and I get the consequent there, R and S. Let's not lose sight of what we were after. We assume the overall antecedent, the P horseshoe Q, that left us after in horseshoe S. We assume the antecedent there, so what we're now after is the S. Once we get the S, then we can begin our discharges. So now that I've gotten down to 8, the S, easy to get. 8, com, and a simp, and there's my S. So now that I've got the consequent of ultimately what I'm after, I'm ready for my first discharge. And it works in the normal fashion, unindent once, and join the first line, my second assumption, as it turns out, and the last line of this particular conditional proof together via horseshoe. And there's my in horseshoe S. Seal that off. All those lines are part of the justification, of course, 4 through 9 conditional proof. And now I've got the consequent, the overall consequent of the conclusion, so I'm ready to discharge again. Unindent, and join the very first line, my very first assumption that is, with the last line. In this case, 3 through 10. 3 through 10 linked together, 3 and 10 that is, linked together via horseshoe. Gets us P horseshoe Q, horseshoe, and horseshoe S. Put in my parentheses, clearly identifying this as the main logical operator, and the justification, consists of all of those lines. I need to seal that off again. 3 through 10, 3 through 10 conditional proof. So that's an example of nested conditional proofs in action. Again, long story short here, anytime the conclusion has multiple horseshoes, that's a clear indication, pretty clear indication that you need to do these nested conditional proofs. But don't make it out to be more difficult than it is. Never deviate from that general rule. Assume the antecedent, take a look at what's left over, and assume the antecedent again. And once you take on those assumptions, once you make the appropriate assumptions, everything will fall into place for you.